Assalamu alaikum wa rahmatullahi wa barakatuh. This is Karim Fazlul, and I am from Group 1. Today we will present our project for our cryptography subject, and the title of our project is Cryptography and Blockchain. So, in my group, we have four members: me, myself, Karim Fazlul, brother Fahmi, brother Ashraf, and brother Muhammad Afdal. So in our project, these are the highlights of our project. So we have discussed the structure of the blockchain, the different types of blockchain that are currently available, and the different cryptographic techniques that are being used in blockchain, and also the general working process, how blockchain works as a network, as a system, and transaction mechanism, how transaction is done, how transaction is validated, and reward, how the reward process works in different types of blockchain, and also the challenges, what are the current challenges that we have in the blockchain technology. So now each of my group mates will present his part.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Afdal Iqbal bin Yaakob, and I will present about the structure of blockchain and how transaction is done in blockchain. So firstly, to get an overview of blockchain, blockchain consists of many lists of records which called block, which in this block contain the transaction that will keep increasing over time. So this record or block is spread across the network of the specific blockchain network, and it's called as digital ledger. So this digital ledger will be shared among the computers of the specific blockchain network. So then every block have information of the block linked to it. So every block will have like the information of the previous block or the future block that have some connection to the current block. And this make the block visible to others, but cannot be changed by any means. Next, as you can see in this picture, is the structure of block, which contain the header part and the body part. So in the header, it have hash of previous block. Hash of previous block is like the hash of the previous block that have linked to it. So it's contain information of that hash. Next is the timestamp. The timestamp contain the block writing data. So when it is write and when the block is written. Next is the nonce. The nonce is the process that is performed by miners, which call minings. So it's contain the data which the miners will mine the transactions to approve to create a validation. Next is Merkle root. Merkle root is a part of the Merkle tree, which the Merkle tree is like the hash binary tree of or the other blocks. So Merkle root is a part of the tree. And then the body will contain the transaction data. So next, I will talk about the how transaction is done in Bitcoin. So as an example, I will take Bitcoin. So firstly, the sender must have intention to send something to the receiver. So both parties will need to have a wallet. That wallet contains addresses that have Bitcoin in it. So the sender will request the transaction via the wallet. And then the second step is the requested transaction will be checked. It will be authenticated, and after it have been has undergo the authentication process, a new block is created. This block is will be used to store the transaction after that. The third step will be the transaction is broadcasted to all participating computers in the blockchain networks, which mean that The transaction will be sent and spread across the computers in the Bitcoin blockchain network for visible to others, and the computers will check and validate the transactions. So this is the process of mining, which the miners will check and perform algorithm check and validates the transactions. So after that, the miners will get a proof of work as a reward. I mean, the miners will get the proof of work and it will get a reward. In Bitcoin, it will get like specific number of Bitcoin. So in the fifth step, the validated transaction are stored into the block hash. The block will be added to the blockchain. So after the transaction is validated, it will be hashed, and the new block will be added to the blockchain after the transaction will be written on it. And then the transaction process is complete. After it is complete, it will be the part of the blockchain, and it's impossible to be changed or altered by other parties, although it's visible to the public. So that's it for the my presentations. Thank you.
So for my part, I will talk about the different types of cryptographic techniques that are being used in blockchain, namely hash function, asymmetric encryption, and the digital signature, how they are being used in blockchain. For hash function, the hash are very important for blockchain. The structure of the blockchain depends on the uses of hash function. As we can see from this figure represents a very high level overview of the blockchain. As you can see, all the data are being hashed. All the data that are kept in a block are being hashed to form the fingerprint of that block, and that hash value used to is being used to form the chain of the blockchain, and this process continues and the network goes. So you can see that the hash functions are fundamental for the structure of the blockchain. uh, as we all know that hash functions are used to protect the integrity of the data, because they are designed in a way that if we do a small changes, it results in a very catastrophic change in the hash value. So this structure is known as a Merkle tree, which is generally a binary tree that are used to hold all the transaction data of the blocks. And as we can see here, the transactions data are being hashed and put in the nodes of that particular block, and then all the values are hashed and put in the header, which are being pointed by the next block, and this way the chain continues until the very newest block. So this slide represent how the Michael tree protects the integrity of the blockchain. As we can see here, if we alter any transaction in the Merkle tree, it invalidates the whole tree. In this slide, the transaction two's data are being altered, so it results in the invalid hash for this R2. Then, because this R2 is invalid, so the root hash that are being stored in the block header also get invalidated. Then it sends a cascading effect, and all the coming pointers are invalidated, so the structure of the blockchain fails. So now I will talk about the digital signature algorithm using the Bitcoin. As we all know, the digital signature are being used for maintaining the authenticity of the transaction, and also to establish the accountability, such as if someone do a transaction then and it's approved, then later he cannot deny the transaction because he already signed it using his private key. So for the algorithm that Bitcoin uses for digital signature is called elliptic curve digital signature algorithm, and the function that generate the elliptic curve that are being used in Bitcoin is called SSFE 256K1. Now it comes to the key pair generation, public and private key generation. The process goes as follows. So first, we need to initiate a very big random number, which is denoted by the small k. Then we multiply k with a generating point, which is denoted by the letter G. And this G is a standard part of the HACP 256K1 elliptic curve that is the standard. So this is predefined. We multiply the random number that we have generated, which is our private key, with the generating point, and it gives us the public key, which is denoted by the big K here. And one thing that we can, it seems from this equation, it seems like we can just multiply both side by the G inverse and we can get the private key, which is not true in practical. This function is defined such a way that it works in one way. We can compute the public key from the private key, but we cannot go the reverse way. That's why also we can share the Bitcoin address and without disclosing our private key. So this slide talks about the address generation of the Bitcoin, how Bitcoin generates its address. So for generating the address, we first gives the public key into the SHA-256 hashing algorithm that generate a hash digest, and that digest is being passed to another hashing algorithm, which is RSC Integrity Primitive Simulation Message Digest, RIPEMD, and it gives us 160 bits of hash digest, and this is the address of the Bitcoin. But in practical case, Bitcoin uses a encoding for representing its address, which is base 58 encoding. So the final hash value goes to the encoding process, and thus we get the address of the Bitcoin. So that's all from my part. Now I will pass on to my group mates to present their parts. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fahmi Fahir, metric number 1811481. So for my part, I will explain how blockchain work and also how does transaction approve. So let's start with the how blockchain work first. Okay, blockchain comprises three significant ideas. The first one is block, second one is miners, and the last one is node. Okay, first block. So each chain comprises numerous blocks, and each block has four fundamental components. The first one is data. So data is it can be any type, it can be anything, but it will depends on the type of the blockchain. And then second, a 32-bit entire number called nonce. So when a block is created, the nonce is generated arbitrarily, which result in the creation of a block header hash. And then the third one is the hash that includes 256 digit number married to the nonce. So for hash, it should be begin with a number of zeros. And then the last one is the hash of the previous block. So the hash of the previous block will effectively create a chain of block. And this technique made a blockchain so secure because if there's a changes that happen in the previous block, the rest of the next block will be invalid. Okay, next, miners. So miners create a new block on the chain through a process known as mining. So miners utilize extraordinary programming to tackle the extraordinarily mind-boggling numerical question of observing a nonce that create an acknowledged hash. And then after they found the correct combination for the hash, their block is added to the chain. When this happens, the changes is acknowledged by every one of the nodes in the organization, and the digger is compensated with monetarily. And then the last one is node. Nodes can be in any type of technological device that maintains track of a duplicate blockchain and keep the organization is running. And then each hub has its own copy of the blockchain, and the organization should be algorithmically approve each freshly executed block in order for the change to be renewed, trusted, and verified. Okay, next is how transaction is approved. So approval in a blockchain is obtained through a process called consensus. So consensus algorithm is a mechanism that allows all blockchain network participants to reach an agreement on the current data state of the ledger and trust unknown peers in the distributed computing environment. And there are several types of consensus mechanism algorithm. So the first one is proof of work. So this technique is to create a cryptographic hash, and then proof of work first used in the blockchain system Hashcash, and then in POW system, blockchain validator must receive data from a block header as input and run it through a cryptographic hash function on a continuous basis. And then the last one is this algorithm is take a lot of electricity and computational power. Then the next one is proof of stake. So this is the alternative of proof of work. And then in this system, blocks are authorized based on the stake of network participant. And in general, the blockchain is protected by pseudo-random election process. Okay, next one. Delegated proof of stake or DPoS. So DPoS system is based on voting system in which delegates vote for their preferred validators to aid in the consensus state of new block. So this validator will also be in charge of validating transaction and maintaining the blockchain network. And then the voting power of each voter is proportionate to the size of the stake of the network. So EOS, BitShare, Steem, Tezos, and other blockchain projects use DPoS consensus to validate their transaction. The next one is proof of elapsed time or POET. So this one is created by Intel. So this algorithm address the computational difficulty of random ladder election and then used in the private blockchain, and this algorithm is depend on randomized timing system for network member rather than mining the hardware. Okay, move to the last one. So this is the last one, proof of authority. So in POA is a sort of consensus mechanism that relies on reputation and trustworthy parties in a blockchain network. It's efficient for private blockchain, and then the POA algorithm is built on the value of identities inside a network, and POA blockchain network are protected by validating nodes that are randomly selected as trustworthy party. So that's all from me. The next part will be explained by my friend.
Okay, next, my name is Ashraf Aiman, and I will explain to you about how reward is done in the cryptocurrency blockchain. So actually, in the market right now, there's 100 of cryptocurrency in the market. So it will be a long video if I try to explain all of it. So I try explain the most popular one, which is Bitcoin and Ethereum. So start with a Bitcoin. So each Bitcoin is basically a computer file which is stored in a digital wallet app on a smartphone or computer. So people can send Bitcoins or part of one to your digital wallet, or you can send Bitcoins to other people. So every single transaction is recorded in the public list called the blockchain. This made it possible to trace the history of Bitcoins to stop people from spending coins they do not own, so making copies or undoing this transaction. So how do you actually earn in Bitcoin? So first is mining. So Bitcoin block rewards are the new Bitcoins awarded to cryptocurrency miners for being the first to solve a complex math problem and creating a new block of verified Bitcoin transactions. So the miners use networks of computer to do this. And every time a new block is created, it is verified by all the other competing miners. Then a new math problem is introduced and the miners start over into the new cycle with the same cycle. So you also can buy bitcoins using the real money, or you can sell things and let people pay you with bitcoins. That's how you earn the bitcoins. That's how the bitcoin rewards are done. So next is Ethereum. So in uh, Bit- Ethereum's actually Bitcoin's main competitor as a cryptocurrency, which is also relies on the block rewards to provide incentive to miners. With Ethereum's, the reward is a digital token called Ether, which is rewarded each time a miner succeeds in providing the mathematical proof of a new block. So as with Bitcoins, miners also awarded a transaction fee known as a gas fee. So unlike with Bitcoins, there is no limit on the number of Ethereum's Ether tokens that can be created, and they are created at much faster pace in seconds versus about 10 minutes. So the total number of blocks in Ethereum's change is larger than the Bitcoin change. So what's what's are the challenges of the blockchain? So the first one is inefficient technological design. So this is one of the major challenges of implementing blockchain. Although blockchain technology has lots of parts, it still lacks in many technological ways. A coding flaw or a loophole is one of the significant point is this. So most of them seem to have a method of false coding and a loopholes. User can utilize these loopholes and hack into the system quickly. So all that talk about security isn't correctly working here. Next is the low scalability. So another one of the challenges of implementing blockchains is scalability. In reality, blockchains work fine for a small number of users, but what happens when a mass integration will take place? So Ethereum and Bitcoin now have the highest number of users on the network, and needless to say, they are having a hard time dealing with the situation. So when the user number increases on the network, the transaction take longer to process. As a result, this transaction costs higher than the usual, and this also restrict more user on the network. So the last challenges are the high energy consumption. So at present, right now, miners are using 0.2% of the total electricity. If it keep increasing, then the miners will take more power than the world can provide. Thus, it is now become one of the primary challenges of this network. So with a high energy consumption, it can be real challenging to move forward with the new cryptocurrency world. So that's all for me. Thank you.